Hi to you watching this video. So for this video, we're going to discuss about measurement of vertical distances. Okay, so this module will explain how to measure vertical distances, methods and instruments used, types of leveling and effect of Earth curvature in atmospheric refraction. Okay, so what is leveling? So leveling is the process of directly or indirectly measuring vertical distances. Okay, directly or indirectly measuring vertical distances to determine the elevation of points or their difference in elevation. Okay, so what are the terms? We need to define them. First, we have the level surface. So it is a curved surface which is at any point perpendicular to the direction of gravity or on the plumb line. It is best represented by the surface of a large body of still water. So a level surface is, for example, this is just a uh, to show you, because we all know that the Earth is not a flat one. Okay, so if we are uh, to imagine it, the Earth's surface may look like this. Take note that a level surface is perpendicular to gravity, and gravity is always directed towards the center of the Earth. So if I am pertaining to this part, therefore the gravity is the direction of gravity is towards this. Therefore, that surface there is perpendicular to the direction of gravity. Therefore, this is what we call the surface, level surface. Okay. Next would be level line. A level line is a curved line in a level surface, all points of which are normal to the direction of gravity and equidistant from the center of the Earth. So what is a level line? Okay? Ayan. So if this is your the profile, if this is ano not profile, if this is your surface, no? The Earth's surface, this is the Earth's surface. We have here the line or the level surface. Okay? So actually medyo magkamukha silang dalawa. Si level line at saka si level surface. Okay? So this is the level surface. Okay? And this is the level line. Next is the horizontal surface. So it is a plane that is tangent to the level surface at a particular point. The horizontal surface is also perpendicular to the line at the same point. Okay? So horizontal surface, for horizontal surface, if I am here, then therefore this surface here is a horizontal surface. It is tangential with my level surface. So this is the level first surface. This is the horizontal surface. It is tangential. Okay? If I am to zoom that, okay, so pag i-zoom natin, ilalapit natin, we can see that this is a horizontal surface. Next, horizontal line. A straight line in a horizontal plane which is tangent to a level line at one point. This is perpendicular to the direction of gravity at the point of tangency, since it means the radius of the Earth is comparatively large. It is practical for most purposes to assume that a level line and a horizontal line are the same for short distances. So this, for example, lipat naman natin. From here, dito naman ako. No? So nandito ako ngayon. Or just imagine kung nasaan kayo ngayon. And yung sight nyo, yung straight sight nyo, that is a horizontal line. That is a horizontal surface. If we are considering a short distance. Yung nakikita ng mata nyo na diretso, that is a horizontal surface, and at the same time, yung tinatayuan nyo is the horizontal surface. Yung nakikita ng mata nyo, that is horizontal line. Okay? Next is the vertical line. A vertical line at any point is a line parallel to the direction of gravity. It is exemplified by the direction taken by a string supporting a suspended plumb bob passing through a point. For ordinary purpose, it is convenient to assume that the Earth is a true sphere with a smooth surface and that a plumb line held at any point on the surface is always directed toward the center. When we say plumb line, pag meron kang hawak na tali, then meron kang pabigat dyan, the direction of uh, your material is always downwards, or it is always to the center of the earth. Therefore, that is your plumb line. So there it is a straight line. It is always going to the center of, or directed towards the center of the earth. Therefore, this is my vertical line at this point. At this point, this is my vertical line. At this point, ito naman yung vertical line ko. Okay? It is always directed towards the center of the earth. Next would be mean sea level. So mean sea level is an imaginary surface of the sea which is midway between high and low tides. It is taken as the reference surface to which most ground elevations are referred. This surface is determined by over averaging the height of the sea's surface. So the mean sea level is uh, the average of the high and the low tide. So this is the mean sea level, and most of the time it is the reference datum, okay, for surveying. And when we say datum, is any convenient level surface coincident or parallel with the mean sea level to which elevation of a particular area are referred. Any surface may be used as a datum when relative elevations over a limited area are needed to be established. So, mean sea level for most surveys in order to locate locations or define areas, the mean sea level is the reference datum. But if we are only surveying a short span of area, then we can allocate a certain datum. And yun yung magiging basis natin, yung datum na yun. Lalo na pag limited lang yung space. Next would be the elevation. So elevation for a particular point, its elevation is the vertical distance above or below the mean sea level of any selected datum. Okay? So if yan. For example, uh my this area is far from, or just a small area, and it's far from the sea, no? So sabihin mo, let's not use the mean sea level. So if I am to have my as an option, if I am to have as an option, I'll be using this point as my datum. So this will be my point 0. Okay? Then as it goes higher, it increases. As it goes lower, it decreases. So this serves as my datum. And elevation is the difference between elevation is the difference in height from my datum. Okay? So elevation is the difference in height from the datum. If this is my datum, then this is the difference in elevation. Okay? And next we have the difference in elevation. So the difference in elevation is the elevation between 2 points, which is in vertical position. Okay? So, for example, this one, the elevation of this, let's say it is 1.05, the elevation of this one is 1.20. 1.20 minus 1.05 is 0.15. Therefore, the difference in elevation, or the difference in vertical distance between these 2 points is 0.15. Okay? And next we have the leveling methods. So leveling methods, we have the direct or the spirit leveling. It is the commonly employed method of determining the elevation of points some distance apart by series of setups of a leveling instrument along a selected route. This method of leveling is also referred to as the spirit leveling since the device used is a spirit level. Differential leveling, double-rotted leveling, three-wire leveling are forms of direct leveling. So in direct leveling, vertical distances are measured above or below a level line, and these values are used to compute the elevation of points or their differences in elevation. Being the most precise method of leveling, it is used when high degree of accuracy is required. So the direct or spirit leveling is like this. Okay? So you have your first stadia, your second stadia, your backside, your foresight. Then you view here the values from the stadia rod. Then you view here the values from the stadia rod. Then from there, we can now get our elevation. Mathematica, we just compute the values using this. We just compute the elevation using this, the values that were given or that were cited. Okay. Next is reciprocal leveling. So reciprocal leveling is the process of accurately determining the difference in elevation between two intervisible points located at a considerable distance apart and when and between which points leveling could not be performed in the usual manner. This method is commonly employed when leveling across a wide river, a deep ravine, or across canyons and gullies where it would be difficult or impossible to maintain a foresight and a backside distance of nearly equal lengths. So this is how reciprocal leveling looks like. Okay, so this is point A and this is point B. Intervisible location. Si point B makikita mo sa point A, si point A makikita mo sa point B. Okay, next we have the profile leveling. So this method of leveling is used to determine differences in elevation between points at designated short measured intervals along an established line to provide data from which a vertical section of the ground surface can be plotted. In the design of roads, railroads, canals, drainage systems, and transmission lines, it is necessary first to obtain a profile of the existing ground. Okay, so this is how profile leveling looks like. So it is very important. Profile. Yeah. So it is very important for us to determine what might be the elevation because it will be involving um, engineering works in the future. Like for example, for roadways, railways, yeah. Okay. So pina-profile mo elevation, 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 elevation. Yeah. You are getting the elevation. BM stands for benchmark. When we say benchmark, it is a starting point. When we say TP, it is a turning point. It is a place where at this point it is foresighted. At this point it is backsighted. Okay. Next is trigonometric leveling. So this method of leveling is employed in determining by trigonometric computations the difference in elevation between 2 points from measurements of its horizontal or slope distance and the vertical angle between the points. The required distances are usually obtained by stadia, triangulation, or direct taping. So this is how trigonometric leveling is being done. So at a certain point or at a certain location, you will station there your instrument. Then you will sight your rod. Then you will have your angle. So take note here, I have the hypotenuse. So if I am interested in getting the vertical distance, I'll be using the angle and I have my hypotenuse. So I'll be using cosine function. Now, if you want to get the difference in elevation between the level of your instrument and the place or the location or the point where you are sighting, then I'll be using sine function, opposite over hypotenuse. Next is stadia leveling. So stadia leveling combines features of direct leveling with those of trigonometric leveling. This method is in fact a form of trigonometric leveling. It can provide reasonable accuracy for preliminary surveys, mapping, and rough leveling, where quick measurements are needed. In stagia leveling, differences in elevation between points are computed from observed vertical angles, and the three intercepts on a rod help each point back-sighted or foresighted. Any surveying instrument may be employed in stagia leveling as long as it has a telescope to read vertical angles and equipped with stagia hairs in addition to the stagia cross hairs. Okay? So, ganito naman siya, stagia leveling. So, you have here your instrument. Then, you have here, you're going to read. You will be having three readings: upper reading, middle reading, and lower reading. Yung sabi dito, you have here, aside from the standard crosshairs. So the standard crosshairs will give you the middle reading, while the where's that? While the stagia hairs will give you the upper and the lower reading. So from there, we can now able to solve for our unknowns. Okay. Next would be barometric leveling. So barometric leveling involves the determination of differences in elevation between points by means of a barometer. So this leveling method depends on the basic principle that differences in elevation are proportional to the difference in atmospheric pressure. The readings of a barometer at a different points on the Earth's surface provides a measure of the relative elevations of these points. It is an accepted fact that the pressure caused by the weight of a column of air above the observed decreases as the observer goes higher in altitude. So for barometric leveling, we are uh, needing the help of a barometer. Okay? So as your altitude goes higher, the pressure decreases. As the altitude goes lower, this is by the way with respect to mean sea level. As your altitude goes lower, the pressure increases. Then if you have your two pressure, then subtract it, then you can get the difference in pressure. Then from there, you can now solve your you can now solve the elevation or the difference in elevation. Next would be the cross-section leveling. So cross-section leveling in highway or railroad constructions, it is often necessary to obtain a representation of the ground surface on either side of the center line. Short profiles at right angles at the line of work are usually plotted at regular intervals for this purpose. This type of data is obtained in the field by a process referred to as the cross-sectional leveling. So this is how a cross-sectional leveling. So we have here the datum, point 1, point 2, point 3 until some point. Then you have here your readings. Okay, so it is very important to have a precise reading. Then for cross section, um, I believe by right now you already know what cross section means. Okay, so dito, yeah. Next, you have a barrow pit leveling, or no, what it is not what cross section means. It is what cross section looks like. Okay. Going back, number 8, barrow pit leveling. Barrow pit leveling is a method of determining the relative elevation of points in barrow pit excavation for the purpose of calculating volume. This type of work usually encountered in the construction of roads and railroads. Okay, inaalam natin yung relative elevation with respect to yung sa mga nahukay na natin. So, for example, here we already know the points at this or the values at these points. Then with respect to barrow leveling, then we can determine the elevation at this point, and from there we can determine the volume of earthworks needs to be done. Or for example, this one. Yan. Okay? Or yan, yung mga yon. Okay? And we have the types of level. First off, we have the dumpy level. So the dumpy level is the most widely used direct leveling instrument. It has a long telescope which is rigidly attached to the level bar. The telescope, which can be rotated through 360 degrees, fixes the direction of the line of sight. Attached to the level bar is a level vial which always remains in the same vertical plane as the telescope. A level head supports the telescope and permits the bubble in the tube to be centered by means of the leveling screws. The whole instrument is in turn supported by means of a tripod. Okay, so um, this is a no, yeah, yeah, yeah. This is a dumpy level because you have the there, you have the screws. This one is used to level the instrument horizontally. Okay. Next is the Y level. So the Y level is very identical to the dumpy level. The only distinct difference between these two instruments is in the manner by which their telescopes are attached to the supporting level bar. So the Y level has a detachable telescope which rests in supports called Y. It can be removed from the Y-shaped supports and turned in for and during adjustment by releasing the two clamping collars which fit across the tops of Ys. Curved clips are used for fasten the telescope in place. So this is how Y level looks like. Okay. Next is the builder's level. So this instrument is used primarily in the different phases of building construction where a high degree of precision is not a primary requisite. It is not a primary requisite. Engineers, architects, and builders use it in the setting of concrete forms, better boards, and in establishing grades of or for earthworks. So this is how builders look like. Okay, builders level. Next is automatic level. So self-leveling features are incorporated in automatic levels. This type of levels has become popular for conventional leveling work because of the ease and speed of their operation. It does not use a level vial and its ability to level itself depends upon the action of a complex pendulum and prism device. This type of leveling instrument is particularly useful where ground is soft or when strong winds blow against the instrument since it can automatically level itself. So this is an automatic level. Okay. Next is tilting levels. So this type of leveling instruments can be tilted or rotated about its horizontal axis. A bullseye level is employed for its quick and approximate leveling. The tilting knob is used to rotate the telescope into a correct horizontal position. Tilting levels are commonly employed for very precise leveling operations and in other general leveling work. It also equipped it is also equipped with horizontal circle which makes it suitable for layout and construction surveys. So this is a tilting level. Okay. Next is for geodetic leveling or level. The geodetic level is basically another type of tilting level. Most of its metal parts are made of invar to reduce the effects of temperature. Geodetic levels are employed in first order leveling work where extreme precision is an important requirement. I repeat, extreme precision is an important requirement. The equipment is this equipment. The equipment is equipped with stadia hairs in addition to the standard vertical and horizontal crosshairs to make it suitable for three-wire leveling. When using the instrument, the observer has to stand erect since it is designed with a high tripod to bring the line of sight way above any intervening ground surface. This was purposely done to lessen the effects of differential refraction of extra long lines of sight. Yan. Okay? So, by the way, what is, sabi dito, refraction? Okay? So, refraction is, if we are to, yeah, isn't it that the Earth's surface is not horizontal? It is somewhat ellipsoid. Okay? So, the shape of the Earth is almost circle, but it is not circle. Okay? So, therefore, if this is a large distance from this point to this point, if we are to view it, you know, through a telescope, it is not a straight line. It is refracted. Okay? So, hindi siya na-view as a horizontal distance, but meron siyang refraction, nagkakaroon ng bend. May bend yung nakikita natin because again, the Earth is not a flat surface. Okay? So, may refraction yung nakikita natin. Next, transit as a level. The engineer's transit has always been referred to as the universal surveying instrument because of its variety of uses. It can provide results which are fairly precise, although not as good as they obtained with conventional levels. This is because the transit has relatively shorter telescope and a level vial. So we have here engineer's transit. No, no. This is not an engineer's transit. But this is another form of level transit. But there are more, this is more modern one, okay? Engineer's transit. So, unfortunately, in the laboratory, we cannot be able to use an engineer's transit due to COVID restrictions since we are in the blended learning mode. But if hopefully soon we can go back to school, you will be able to see this in our laboratory. Okay, this is available in SLU. This is what we use for surveying field in our surveying activities. Next, we have the laser level. By the way, the advantage of this is it is very, the range of its use is very wide compared to other transits. But of course, the precision is less compared to other old transits or other transits stated. So, laser level, a new innovation introduced to surveying operations, is the use of lasers. A laser system is a separate unit equipped with a portable power supply and may be a helium neon laser or gas laser. So, actually, medyo nagiging sikat na itong laser level na to, no, for geodetic engineers. So, for laser level, they are using the aid of laser. Okay, so meron niyang laser. And mas mabilis daw and precise daw siya according to them. And in terms of technology, it is advanced. Alright, number 9, hand level. The hand level is a handheld instrument used on surveys involving short sights and where a lower order of accuracy is sufficient. So, hindi masyadong low accuracy lang kailangan natin, then this can suffice. It has been proven useful in reconnaissance surveys, in cross-sectioning to obtain additional rad readings on sloping grounds, and in taping to determine of the tape is held horizontally during measurement. This instrument also provides a quick way of determining how high or low the engineer's level should be set up in order to be able to read a leveling rod held a certain distance away. So, hand level is this. This is how a hand level looks like. Okay? Okay, differential leveling. So differential leveling is a technique used to determine differences in elevation between points that are remote from each other. Differential leveling requires the use of surveyor's level together with the graduated measuring tools. So these are your graduated measuring tools. Okay. An elevation is a vertical distance above or below a reference datum. Okay. So BS, BM, FS, TP. So what are those? BM stands for benchmark, a fixed point of reference whose elevation ID either known or assumed. So this is where my elevation, the first elevation is known, okay, or assumed. Backside, a reading taken on a rod held on a point known to be known or assumed elevation. If this is the direction of my stationing, so this is my stationing, the direction of my stationing is towards the right. Therefore, if my instrument is set up here and the direction of the stationing is towards right, if I am to um, if I am to anong English ng silip? If I am to sight, yun. If I am to sight the back, that is what we call back sighting because the direction of my stationing is towards right. Therefore, the back is towards left. Therefore, we call this back sight. And the sighting towards right is what we call the foresight. Okay? This is what we call the TP. What is TP? Turning point. An intervention point between two benchmarks upon which point foresight and backsight rod readings are taken to enable a leveling operation to continue from a new instrument position. So this is a TP because it has a foresight, and if I am to transfer my instrument to another position, it will also be having a backsight. Okay? So take note for the HI. HI stands for height of instrument. Benchmark plus backsight, I repeat, benchmark plus backsight is equivalent to the height of instrument. Height of instrument minus foresight is equivalent to the elevation of the turning point. Okay, so we will be using this formula. Okay, so this is how it looks like. So you have here my benchmark 1, it is the start, and my benchmark 2 is the last position or last point. Okay? Benchmark 1 is the first position or point. Benchmark 2 is the last point. So this is my TP1. This is my TP2. The direction of leveling. So since this is the direction of my stationing or leveling, uh, the, uh, uh, the site taken that is towards the right or the direction of leveling is foresight. The site which is taken opposite the direction of leveling is what we call the backside. Okay, so this is my TP1, this is my TP2. Okay, so let us now try our illustrative problem. So we have here the illustrative problem for differential leveling. So determine the elevation of the benchmark 2 from the following notes. Check arithmetic by adding the foresights and the backsights. Okay, so this will just be a simple addition and subtraction. Okay, so we just need to have the elevation of the first station. Okay, then from there we can determine any elevation of any points that we want to know. Okay, so for example, we have here benchmark 1. We know the elevation here. Now to get the elevation of BM2, we are going to have our location of our stationing. So for example, we have here the elevation of 50. Okay, so 50 plus the backside is equivalent to the height of the instrument. Okay, height of instrument minus the foresight is equivalent to the elevation at this station. Okay, backside plus height of the backside plus elevation of this station is equivalent to the height of the instrument. Height of the instrument minus the foresight is the elevation at this station. Elevation of this station minus the backside of this instrument is the height of this instrument. And height of this instrument plus or minus rather minus the foresight is the elevation of BM2. Okay? So, ganun lang naman yung procedure natin. So, yan. So, I prepared here a Excel para mas madali natin siyang ma-visualize. Okay? So, height of instrument. So, elevation. So, I just simply copied the data here. So, you have 1.21, 1.21, 6.2, 6.2, 4.82, 4.82, 3.03, 3.03, and so on. Okay? Now, to get the elevation of the first turning point, it will be simply 50 plus 1.21, so that is 51.21. Now, to get the elevation of the turning point 1, it is height of elevation 1, take note, height of instrument minus the foresight, and this is the foresight of this setup. So 51 minus 4.65 is equivalent to 51.21 minus 4.65, 46.56. So this is 46.56. Okay? Next, 46.56 plus the backside. Nandito na tayo. We are already here. 46.56. This is the elevation. 46.56 plus the backside of this setup, which is 6.2, is equivalent to 52.76. So that is 52.76. So yung height ng instrument natin dito is 52.76. Okay, now to get the elevation of the turning point, ito yung turning point number 2 natin. It is height of the instrument plus the foresight of this setup. So height of the instrument, height of the instrument minus 3.11. So that is 49.65. So that is 49.65. Okay? Next, 49.65 plus 4.82 is equivalent to 54.47. So 54.47. So 49.65 plus 4.82 is equivalent to 54.47 minus 5.22 minus 5.22 is equivalent to 49.25. 49.25. Okay, so itong 54.47, ito yon, height nito yon. So 54.27 minus plus the backside is equivalent 49.65 rather. Ito, 49.65 plus 4.82 is equivalent to 54.47. But dito kasi ano lang tayo, we only have 2 turning points. Okay? Dito is 3. Okay? So ganun lang yung procedure natin. So we already are in the elevation of TP3. So to get the elevation of BM2, it is simply 49.25 backside plus elevation plus the backside. So that is 49.25 plus 3.03. And that is equivalent to 52. 52.28. Okay, and to get the elevation of the benchmark number 2, it is simply 52.28 minus 3.16, and that is equivalent to 49.12. Now, according to the instruction, let us check the arithmetic by adding the foresight and the back sides. So we have here, so this is equivalent to sum and copy. No. Okay. The sum is 16.14. So the difference is equivalent to difference of this my foresight, backside minus foresight is equivalent to negative 0.88. Okay. Now, to get the value that we're going to uh, or check, it is elevation elevation minus the difference is equivalent to 50. So we have here 50 minus, or hindi, wag na natin i-minus, plus this. That is 49.12. So this one and this one should be the same. And since they are the same, ibig sabihin, our answer for elevation of the benchmark 2 is correct. Okay, so from your module, let's check. It is 49.12. So that is 49.12. And that is also 49.12. Okay, now another way is to check the elevation of the BM2. So elevation of BM2 minus the elevation of BM1. Elevation of BM2 minus elevation of BM1 is equivalent to, okay, is equivalent to this, no, BM2, no. We should be starting on BM2 minus BM1. Dapat parehas din sila sa difference no backside at saka foresight. Okay? So, pwedeng ito na lang diretso nyo para mas madali. So, you have the backside minus the foresight, you have the difference. So, BM2 minus BM1, you have the difference. And if they are the same, then your answer is correct. Okay, so we have here problem number 2. A differential level network is run from BMRIPP through A1, TP1, B, and closes back on BMRIPP on figure number 2. So the elevation of BMRIPP is 820.12 feet. And we also have here our backside and foresight readings. So this backside and foresight numbers shown in figure are the backside and foresight reading respectively at each instrument setup. These are shown only for example purposes. This is not how readings are recorded in the field. Okay. So the main instrument in computation sequence carries an elevation from backside point through the instrument to the foresight point. In figure, the notes are recorded and reduced, reflecting to this process. So we know that we have the elevation of the first point, then the backside, that would give us the elevation of the instrument or the height of the instrument. Okay, then to get the elevation of the next point, it is the height of the instrument minus the foresight. Okay, so let's try to tabulate. So we have here the BMRIPP. Okay, so we are pertaining to this instrument here. The elevation of BMR RIPP is 820.12. Then the backside reading is 10.92. Okay? So, next, dito naman natin makukuha yung height ng instrument. So, height of the instrument would be 820 plus 820.12. Wait lang. 0.12 plus 10.92. So, that is 831.04. 31.04. Okay? Tapos, next would, nandito na tayo. So, we are foresighting point A. So, this is point A here. The foresight is 3.42. So, 3.42. Then, to get the elevation, isubtract natin siya sa 831. That would give us 827. So, 827.62. Okay? Tapos, from there, dito na tayo, lilipat na tayo, nandito tayo sa point A, then lilipat na tayo for this, to this station. The backside is 2.73. So, the backside is 2.73. Then, we can now get the HI. So, HI is equivalent to this plus this. Okay? Then, kukunin natin yung foresight. Yung foresight is 12.28. So, that is 12.28. Then, we can now get the elevation of TP1. So, we already are in TP. So, TP1. So, the elevation is equivalent to this plus this. Okay? Then, we have our backside for TP1. We have 6.34. 6.34. Then, we can now get our, mali. It should be minus. Okay? HI minus FS. Okay, so we have here, we can now get the HI, the height of instrument for TP1, and that is equivalent to, that is equivalent to this plus this. Then, makukuha na natin yung, alamin natin yung foresight. Foresight ni TP1, that is backside. This is the foresight. Nandito na tayo. Okay? So, foresight, tama. This is the foresight that is 8.68. 8.68. Then, we can get the elevation of B. So, this is point B. The elevation is equivalent to this minus this. Okay? Then, kunin natin yung backside ni B. Andito na tayo. The backside is 10.39. So, 10.39. Then, we can get the elevation of the height of the instrument. So, that is equivalent to this plus this. Okay. Tapos, kunin natin yung foresight, which is 6.04. 6.04. Then, we can get the elevation. And that is equivalent to this minus this. And, bumalik na tayo kay BMRIPP. Okay? Okay. So, we can get the sum. There's by the way, there is also another way of solving. Okay? So, we have here we can get the sum from this point to this point to this. Okay? So we can have it by elevation, of and dapat parehas yung magiging sagot natin. So elevation RIPP, RBM, RIPP is equivalent to, okay? So we have here the elevation at the starting point minus the summation of the backside, plus rather, plus summation of the backside, plus, take note, ang backside natin ina-add, di ba? So, sa procedure natin dito. Then, we are going to subtract the foreside because sa procedure natin kanina, sinusubtract natin si foreside. Okay? Minus this. And we should have the same. Wait. Wait. This minus and plus this minus this. And that's your elevation BMRIPP. Okay? So, they should give you the same answer. Okay? Sir, bakit ganun? Bakit nag-start tayo sa BMRIPP and nag-end tayo sa BMRIPP but the elevation is the same. There is a difference of 0.04 meters. And we can blame that to human error. Okay? And minimal lang naman yun. 0.4 and 0.4, though that's 400 mm. But we can blame that to human error. Okay? So, next here is profile leveling, the process of determining differences in elevation along a fixed line at designated short measure intervals is referred to as profile leveling. So, emphasize lang natin, along a fixed line. So, it is a fixed line and designated short measure intervals. So, if you can see here, this is a designated line, BM road to BM of the store, benchmark of the road, benchmark of the store. And sabi dito, short measure. So if you can see, the stationing are short measured. Okay? So profile leveling, which yields elevation at definite points along a reference line, provides the needed data for designing facilities such as highways, railroads, transmission lines. Okay? So, profile leveling is very important in most especially for highways, railroads, and transmission lines because it changes the design. The elevation might change the design of the structure. So, reduces levels at various points at regular interval along the line is calculated. After getting the RL of various points, the profile is drawn. Normally, vertical scale is much larger than horizontal scale for the clear view of the profile. So, larger vertical scale compared to the horizontal scale is far larger because we want to see the profile. So, kumbaga ano yung itsura in reality nung ating terrain. That's why we are trying to transfer what is actual to paper. Okay? So, what are the definition of terms? So, profile, a curved line which graphically portrays the intersection of a vertical plane with the surface of the earth. So, this is the vertical plane and this is the surface of the earth. So stationing, a numerical designation given in terms of horizontal distance, any point along a profile line is away from the starting point. So these are your stations. This is a station, 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 up to here. This is also station. Okay, station yang mga yan. So for sight, this sight, which are also known as the ground rod readings, are taken along the center line of the proposed project to provide an accurate representation of the ground surface. So for example, what we are going to build are roads. Okay, so for road, we know that a road has a center line. So it is very practical to determine or to have our measurement at the center line because you have the left lane, you also have the right lane. So if we are going to have it at the center line, then we can have a better perspective. Okay, and mas tama yung magiging design natin. So, full stations are points which are established along the profile level route at uniformly measured distance. So, these are uniformly measured distance, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Uniform ang distribution ng distance niyan. Therefore, we call this full station. So, what about the small stations here? The small stations here are not uniformly distanced, and that is what we call the plus stations. So any other intermediate points established along a profile level route which is not designated as full station is called a plus station. Therefore, this is a plus station. Okay? And profile paper, a special heavy grade graphing paper used for plotting profiles. Okay? So we have here an illustrative problem. Okay, so for this illustrative problem here, we're going to skip this one because we have a missing information dito. So we proceed with this one. So example, so compute the elevations of points 1 through point 5. So point 1 to point 5. If the elevation of the benchmark is 22.13. Okay, so of course I already prepared here an Excel so we can answer it ng mabilis. Okay? So, ano ba yung IFS dito? IFS stands for Intermediate Foresight. It is still actually a foresight. It's just that kumbaga yan yung isiningit lang siya. Isiningit lang siya in between our foresight. So, if you're going to check here carefully, andito yung instrument natin, nagdagdag lang tayo ng mga iba pang reading para mas mabasa natin yung profile or makita natin yung iba't ibang elevation before tayo pumunta kay TP1. Therefore, IFS is still FS in the sense na siningit siya in between your instrument and your foresight. So, parehas pa rin yung equation natin. HI is equivalent to elevation. So, we have here elevation plus backside. Then for the elevation, it is okay. It is height of instrument minus foresight. Okay? So yan, palakihin natin. So that's it. So we can now proceed. Okay, so I already copied yung data. So for the benchmark, the elevation of the benchmark is 22.13. So for the height of the instrument, it is simply the elevation. So it is elevation plus the backside. Then that is the elevation of your height or the instrument or the height of the instrument. Ito na yun. Okay? Now, for example, this is your FS1 and this is your FS2. Tapos ito yung ating TP1. So, we are still going to base it on the height of the instrument. So, for the elevation, that is still, it is height of the instrument minus the foresight. Again, IFS is still a foresight. then yun na. Yun na yung elevation natin at FS1. So, ito na yun. Okay? Just for example, pero hindi ito yun. Ibang data yan. Okay? So, again, for IFS number 2, it is height of the instrument minus the foresight, intermediate foresight. Therefore, the height of the instrument at point 2 or the IFS2 is 23.29. Okay? Next would be the elevation of your turning point. Okay? May turning point na tayo. For example, nilipat na natin siya dito. Ay, hindi. Ililipat na natin siya dito. But we still have our foresight. So, we have here the elevation or the height of the instrument minus the foresight. Minus the foresight here. And you have there the elevation. Now, what would be the height of the instrument? Okay? The height of the instrument, ito na yon. The height of the instrument would be elevation, that is equivalent to elevation plus, no. We have here elevation plus the backside. Okay? Next would be for the fourth, we have here height of the instrument minus the foresight. Okay? And for the height of the instrument, that would become 23.61. 23.61, that is H elevation plus the backside. Okay? Then for the elevation of 0.5, that is equivalent to height of the instrument minus the foresight. And therefore, the height or the elevation at 0.5 is 23.74 meters. Okay? So, medyo nalito lang kayo or medyo nalito lang siguro sa part na dito kasi nilagyan natin ng space between the height. Okay? Yung sa height tapos bababa papunta sa foresight. Dito, hindi. Hindi tayo naglagay ng space in between. Yun lang yung difference. Okay? But again, the computation are the same. Okay? So, yan. Kung papansin niyo nagkaroon lang tayo ng space dito. Hindi natin tinabi. Okay? So, ganito kasi yung ginawa natin dito. Nakaganyan siya. Okay? Tapos, foresight, diretso na dito. Okay? Ay, foresight, elevation, diretso na dito. Ito, minus ito, lalabas doon. Okay? So, medyo naiba lang yung process. Okay? So, if you are going to try to answer this problem here, where's that? If you want to try the problem here, ganun siya. So, may elevation ka plus backside, makukuha mo yung height ng instrument. Para makuha mo yung elevation nitong station 0 plus 0, 0, you have here height minus IFS, height minus 2.2, height minus 1.2, and height minus 0.09. Intermediate foresight. Now, this time, nagkaroon ka ng turning point, aalamin mo naman yung elevation ng turning point. Okay? Yan. Of course, after measuring the horizontal distances, we will now be proceeding with measurement of the vertical distances. So, we are already on module number 3. Okay? So, we have here the 3-wire leveling. So, 3-wire leveling is the process of reading and recording a rod reading for which of the 3 horizontal crosshairs on each shot, then averaging the readings for agreement with the center reading. This method is most accurate as it gives immediate results and a check or confirmation of rod reading. If a difference is detected, a check can be done on the spot before moving on. Okay, so we have been telling about crosshair. So what is a crosshair? So if you're going to see a telescope, if you're going to check a telescope, this is what you call the crosshair. This is the guide. Okay, so for a three-wire leveling, this is the middle crosshair. Then for you have an additional upper horizontal crosshair and a lower horizontal crosshair. Okay? So this is how a setup for a three-wire leveling is. So you have here your level. So you have here your horizontal line of sight. You have here your upper reading. You have here your lower reading. And you have here your elevation of the unknown based on the datum. You have here your HI, your height of instrument, with respect again to your datum. And for this case, our datum is the mean sea level. HD is the horizontal distance. Okay? So A here is the upper stadia reading. So this is the upper stadia reading. B is the uh, lower stadia reading. And C is the horizontal crosshair reading on rod reading on P. Okay, so this is point P. This is point L. Stadia intercept, or the difference between the upper stadia and the hair reading and the lower stadia hair reading. So upper stadia hair reading and the lower stadia hair reading, get the difference, that would become your stadia intercept, or that is your S. So M is the median or the mean of the three hair readings. M is the mean of the three hair readings. HD is the horizontal distance from the level of the rod held at P. So from this point to this point. K is the stadia interval factor. C is the instrument constant. And HI is the height of line of sight above datum or mean sea level. So for this instrument constant, it is given by the manufacturer, no? So the following equation are used in three-wire leveling. So S is equivalent to A minus B, or stadia intercept is upper minus lower stadia hair reading. Mean is the reading ABC divided by 3. HD is KS plus C, where K is your stadia interval factor times your stadia intercept plus the instrument constant. Excuse me. And elevation of P, so this one, elevation of P here is HI minus the median, or the mean rather. So height of the instrument minus the mean. So you can get your elevation of P. Okay, so let's try this example. Okay, so we have here an engineer's level with stadia constant of 0.3 meter was set up on the line between A and B. The following crosshair readings were observed. So if we are to interpret this, you have here point A and point B, and your instrument was set up in between point A and point B. So you have an upper reading. When it is at point A, the upper reading is 1.3, and when it is at the middle reading is 1.175 and the lower is 1.020. And for the rod position B, we have upper reading of 1.972, a middle reading of 1.854, and a lower reading of 1.736. Okay, so we are to determine the reading, or the distance, or the horizontal distance. We are to determine this. So based from our definition, this is HD. So what are the given? Okay, so let us try to resolve even though it's already answered in your module. Okay, so according to the given, we have a stadia constant. So that is C is equivalent to 0.30 meters. Okay, we have our stadia interval factor as 100. Okay, so for the formula, we have HD is equivalent to KS plus C. Okay, so let's have there HD point A is equivalent to the stadia interval factor, which is 100. So 100 times, what is the S? S stands for stadia intercept, and the stadia intercept is the difference between the upper reading and the lower reading. Okay, so the upper reading is 1.330 minus the lower reading of 1.02, 1.020. plus the constant, Staggia constant, which is equivalent to 0.30. So HDA is equivalent to 100 times 1.33 minus 1.02 plus 0.3. Therefore, that is 31.3 meters. Okay? So, 31.3 meters. Next would be at point B. So, we have here HD. B is equivalent to KS plus C. And K is, again, it is equivalent to 100 times the Staggia intercept, or S. We have here the upper reading minus the lower reading. So 1.972 minus 1.736 plus the Staggia constant of 0.3. Okay, so we have here 100 times 1.972 minus 1.736 plus 0.3. And that is equivalent to 100. Okay? Or, wait, may mali. Wait. This is times 23.9. So, this is 23.9 meters. Therefore, HD is equivalent to HDA plus HD. HD is equivalent to HDA plus HDB. And that is equivalent to 31.3 plus 23.9 meters. Therefore, HD is equivalent to 55.2 meters. So the distance between point A to point B is equivalent to 52.2 meters. Next is Earth's curvature and atmospheric refraction. So when we are surveying a small area, like for example, it is a lot area, it is as small, okay? So we can neglect the effect of the curvature of the Earth, okay? Because the error is very minimal and is negligible. But when we are measuring a distance between point A and point D, which is very big, like for example, it is in kilometers, hindi na natin maneneglect yung tinatawag nating vertical error. We can no longer neglect what we call the vertical error. It is the distance between point B and D. Because we thought that what we are seeing is horizontal, but in reality, it is not horizontal because the Earth is not flat. Okay, so that is the effect of the Earth's curvature. And since the Earth is not flat, nagkakaroon tayo ng vertical error. And next is the atmospheric refraction. So for the atmospheric refraction, all lights are being bended by the atmospheric pressure. It is a combination of atmospheric pressure, temperature, and geological position. So, ang akala natin, all while it is a horizontal line of sight, it is not a horizontal line of sight because it is being bended by the atmospheric pressure. And that is what we call the atmospheric refraction. Okay? So, curvature effect. The effect of Earth's curvature is the amount by which the level surface passing through point A departs from a horizontal plane at distance AD from the point of tangency. And next is refraction correction. Rays of light passing through the Earth's atmosphere in any direction other than vertical are refracted or bent from a straight path. This bending usually takes place in a direction towards the Earth's surface under normal conditions of temperature and pressure gradients. So, unfortunately, you were not able to do this in your physics laboratory during the short term due to pandemic, pandemic restriction, because we are still in the blended learning. So, but I hope you were able to do this during your senior high school or high school in your physics subjects. So if the light will pass through on a vertical vertical direction pass through the Earth's atmosphere, it will not be bent. But if it is otherwise, if it is not vertical or otherwise, then it will be bent by the atmospheric pressure. Same through with our line of sight. It is being bent by the atmospheric pressure. So to correct that, we have the formula HCR is equivalent to 0.0675 K squared. So HCR is the combined effect of the Earth's curvature and atmospheric refraction, measured from the curved line to tangent line in meters. So from this point up to this point, okay? Point of tangency. Yan, dito yung tangency natin. Okay? So, such bent rays, So, K is the length of the line of sight. And take note, K is in kilometers. Okay? So, let's try this illustrative problem. We have here the problem. Disregarding the effect of tides and waves, determine how far out from the sea a boat will be when the light of its man, 18-meter above the water, disappear from the sight of a man on a shore whose eye level is 1.5 above the water. Okay? So if we are to draw that, if this is your, for example, this is your sea, okay, then this is the shore. So we have here, so this is 18 meters and yung isa is 1.5 meter above the water. So that is 1.5 meter. So the 1.5 meter here is the combined correction of the combined correction of the man in the seashore, and 18 is the combined correction of the man on the boat. So what would be their total distance? So this is what we are looking for. This distance here is equivalent to K. So this is K man and this is K on the boat. Okay? So our formula for the combined correction or combined effect of the Earth's curvature and atmospheric refraction, HCR rather, is equivalent to 0.0675 K squared. Okay? So let's start with the man. So we have here HCR. So let's say that is the man is equivalent to 0.0675 K squared. Okay, so we have here 1.5 meters is equivalent to 0.0675 K squared. Okay, and sabihin natin that is K1. Therefore, K1 is equivalent to 1.5 is equivalent to 0.0675 times alpha x squared. And K1 is 4.71 kilometers. Okay. Next, we have HCR on the boat. That is equivalent to 0.0675 K squared. So we have 18 meters is equivalent to 0.0675 K squared. And so let's say that's K2. So we have here 18. So we have 18. So that is K2 is equivalent to 16.33 kilometers. So, mali yung drawing natin. It should be, it is 1.5 above meters. So, nandito siya. So, nandito yung tao. So, 1.5 above. Tapos, yung nandito, yung isa, nandito naman siya. Okay? So 18 meter above water, and you have here 1.5 meter above water. Okay, so we need this. We have already have the correct vertical error, and we already have here the vertical error. So from there we can get the K. So K is equivalent to K1 plus K2. So K is equivalent to 4.71 plus 16.33. K therefore is equivalent to 16.33 plus 4.71 is equivalent to 21.04 kilometers. Okay. Another one is trigonometric leveling. So trigonometric leveling is so named because it uses total station instruments or TSI, slope distance, and zenith angle measurements to mathematically compute an elevation difference, which, with a few more bits of information, can be used to determine a point's elevation. Using appropriate procedures and controlling errors, elevation accuracy can be better than zero point 0.1 feet. Because trigonometric leveling is not limited to a horizontal line of sight, it is more flexible and provides faster elevation data collection than differential leveling. So trigonometric leveling is the branch of surveying in which we find out the vertical distance between 2 points with the help of some measurements of the vertical angles and the known distances. So the known distances are either assumed to be horizontal or geodetic lengths at the mean sea level. So the distance are measured directly as plane surveying, or they are computed in a geodetic surveying. So the trigonometric leveling can be done in two ways. Number one, the observations taken from the height and a distance, for the height and distances. And number two, you have geodetic observation. In the first, we can measure the horizontal distance between the given points if it is accessible. We take the observation of the vertical angles, then compute the distances using them. So if the distances are large enough, then we have to provide correction for curvature and refraction, and that we provide to the linearly of the distance that we have computed. So it is simply a function of trigonometric functions. So we have the SOHCAHTOA. Okay, so if you have an angle, you have one side, then we can solve everything. Okay. So, in the second, geodetic observations, the distances between 2 points are geodetic distances, and the principles of the plane surveying are not applicable here. The corrections for the curvature and refraction are applied directly to the angles. Okay? So, yung equation na trinay natin kanina, yung HCR, this can only be applied on plane surveying. Okay? Plane surveying yan. But if we are already using the geodetic observation, then we will directly apply the correction on the angle. Okay? Now, we will discuss various cases to find out the difference in elevation between 2 points. The point, the 2 points are known distances. So you have point A and point B. The base of the object is accessible. So when 2 points are at a known horizontal distance, then we can find out the distance between them by taking the vertical angle observation. Okay? So we have here the vertical angle. So we have here alpha. And we have here our instrument located at point A, and our staja is located at, or our rod is located at point D. Then this is my line of sight. Since I already have my angle, then I have my staja reading here, then I can do my computation. Okay? Horizontal distance times the tangent times tangent vertical angle is equivalent to the vertical difference between the two. Okay? So let us try this example here. Okay, so we have here a vertical angle of negative 12 degrees, 25 minutes measured to the top of the water tank from an instrument set up on a hill 585 meters away from it. The telescope of the instrument is 1.45 meter above the ground, whose elevation is 462.73. Making due allowance for the Earth's curvature and atmospheric refraction, determine the elevation of the base of the water tank if the tank is 32-meter high. Okay, so this is the water tank and it is 32-meter high. And we have here our instrument. It is set up on a 462.73 meter elevation, and the height of the instrument is 1.45 meter above the ground. The horizontal distance between the instrument and the tank is equivalent to 585 meters. So we need to determine what would be the elevation of the base of the tank. Okay, so the first thing that we need to do is to determine this. Okay, so distance V. Then we need to add the height of the tank. Then we need also to include the effect of the Earth's curvature in atmospheric pressure. Okay, so in solving V, since we already have an angle and we have one side, we can solve for V. Okay, so using tangent function. So tangent 12 degrees 25 minutes is equivalent to opposite, and that is V, opposite over adjacent of 385. Okay, so 385.0 meters. V therefore is equivalent to 385 tangent 12 degrees 25 minutes. So V is equivalent to 385 tangent 12 degrees 25 minutes. Okay, so that is equivalent to, wait. It's not 300, it's 500. 585. Okay, so 585. So the total vertical distance is equivalent to 128.80, and that is in meters. Okay, but that's not it. No, we need to consider the effect of curvature and refraction. So HCR is equivalent to 0.0675 K squared. Okay, so that is equivalent to 0.0675 times. We have here a distance in meters, so we need to convert that in kilometer. So 585 divided by 1000 quantity squared. So HCR therefore is 0.0675 times 585 over 100 1000 quantity squared. So that is 0.023, and that is in meters. Okay. Then the next is we need to determine this distance here. Okay, pag nakuha na natin itong distance na to, pwede na natin i-subtract with elevation ng P with respect to the datum. Then yung DEPB natin is also with respect to the base of the instrument, so we can get the difference. Okay, so the elevation, or pwede natin i-diretso. So the elevation of the bottom of the tank, is equivalent to 700, what's that? No. The elevation is 400 462.73 meters. Okay? Take note, this is your V. So sa V, we have, we're going to subtract V. Yung V natin is 128.8 meters from the line, horizontal line of sight of the transit. So 128.8, then we're going to subtract the height of the instrument, which is 1.45 meters. Then we also subtract the height of the tank, which is 32 meters. Okay? Then we include the correction for the due to Earth's curvature and refraction. So plus 0.023. Okay? So i-double check natin. So we have here yung V. Yung V natin, 1.28 minus the height of the instrument. Tama. Minus height of the water tank. Then plus the effect of curvature and refraction. Okay? So wala na tayong dapat na i-ano. So that's it. So the elevation of the bottom of the tank is equivalent to 462.73 minus 128.8 minus 1.45 minus 32 plus 0.023. Therefore, the elevation of the bottom of the tank is equivalent to 303.403 meters. That is the elevation here. Okay?